Good morning, everyone, and thank you for joining this presentation. Today, I will talk about our ongoing project called Roset in collaboration with Antonio Prado and Tommaso. So we all know that routing security is really important nowadays, and the MANRS initiative is playing a key role in making the internet a safer place. In this talk, I will mainly focus on the MANRS network operators guidelines and briefly summarize them in this slide. They are coordination, global information, anti-spoofing, and filtering. And these are the 4 actions that a network operator must perform to verify MANRS compliance. Okay, after reading them, I ask, let's assume I'm a network operator and I want to ensure that my network is MANRS compliant. How can I verify this? So, the reality is that there is no automatic and comprehensive tool to verify MANRS compliance. And so the validation is done manually by the operators and becomes a cumbersome process because they have to manually verify and the configurations and policies. And this also makes it difficult to replicate the process in case this is needed. So yes, while ensuring MANRS compliance is crucial, it's not an easy task. So to address this problem, in this talk, I will briefly present Roset, which is the first open source tool to automatically verify MANRS compliance. Since the time is not enough, I will briefly go inside the process. And so first, the candidate provides the AS number, and from this we can get the IRR entry and parse the outnum objects. And for now, we rely on a manual parsing of the RPS lang syntax, but we plan to switch to better services such as IRRD. Then we also take the latest rib dump from a route collector, and from this we can filter out the routes originated by the candidate AS by checking the AS path. So now we have a prologue script that will check if the networks announced to the transits in the wild are the same as the ones declared in the IRR entry, and vice versa. Okay. At this point, we can take the vendor configuration that is provided by the candidate, and we need to transform it into an agnostic format that can be easily processed in the rest of the pipeline. So how can we do that? Currently in Roset, we exploit Batfish that understands most of the vendor syntaxes and transforms them into a unified format. But during the process, we noticed that Batfish output lacks some important information, such as it doesn't support IPv6. So we use the Batfish output as a baseline, and then we extract the missing information with our custom parser. Indeed, we use the Batfish in this phase of the project to fast iterate on it, but we plan to switch to a custom full parser made by us. So now we have a data structure that holds the important information into an agnostic format, but we don't know the relationships between the ASs inside this configuration. And so we again rely on the IRR entry to set the configurations between the autonomous systems. And for being compliant to a realistic network, we plug a dummy OTT, which is connected to all the providers of this small network. So now we again use the rib dump to add on each autonomous systems the prefixes that are originated by each AS. So these sum up the small network that behaves like a realistic one connected to the candidate. In this example, we only show how Roset handles the direct peerings, but we also support multi-op peerings from the candidate AS towards the other autonomous systems with a slightly complex syntax and logic. So at this point, we transform this intermediate representation into a runnable network scenario. And to run this scenario, we rely on the emulation and particularly on Kadara, which is an open source network emulator based on containers. Each autonomous system of this representation is then converted into a router. And For all the routers except the candidate one, we use FR routing as the routing suite. As for the candidate router, we use the specific vendor container that is derived from the configuration provided by the candidate. And for now, we support Cisco iOS XR and Junos, but indeed we plan to support other vendors since the architecture can be easily extended to do that. So after waiting a bit for the network convergence, we can start performing the actual verification. Before that, we had 2 hosts that will be used to perform the tests. So for time reasons, I will only show how the anti-spoofing check is performed. For doing that, we take the providers, and for each one of them, we first add a client inside the same autonomous system. We then assign both IPv4 and v6 addresses to each client. And the challenge here is to choose subnets that are correctly announced and mutually reachable from the information that we have at our disposal and from the emulated network. Another challenge is to select a valid random IP address to assign to the internet host. And this address and subnet should not overlap with the other networks announced inside this small network. And once we choose it, this subnet will act as the malicious subnet. So now we perform the actual check. And to do that, we put a TCP dump on the internet host to sniff packets. And using SCAPI, we craft a ECMP packet from the candidate client. And this packet will have the spoofed IP as the source and the provider client IP as the destination. Now we send this packet and 2 conditions can arise. If the packet is forwarded by the candidate router towards the provider, then we check if the packet is then received by the internet client. If so, it means that the configuration is not compliant with this action. In another case, if the candidate correctly blocks the packet, so no packet is received by the internet client, and so the configuration can be handled as compliant. As a double check, we also verify that legit packets are correctly forwarded and received by the provider host. So to conclude, I briefly presented ROSET, which is the first tool to automatically verify MANRS compliance. ROSET allows network operators to finally test their configurations without relying on manual and error-prone procedures, and this will surely help in the adoption of the MANRS principles if this project becomes widespread, which I hope. Indeed, the work is preliminary, and sure there is a lot of future work. The first step is to extend the verification from a single router to multiple routers. Then we plan to extend the verification to also IXPs and the CDN cloud providers. Moreover, the tool was born to verify MANRS, but we also plan to have additional support, for example, to validate their PKI deployment of the candidate or ASPA. Another cool feature that could be implemented is to release a code, for example, a certificate that is a tangible proof that a certain network is MANRS compliant. And lastly, the tool is right now CLI based, but we plan and we hope to pack it into a web UI. So I'm at the end. Thank you for the attention. And as I said, ROSET is an open source tool, so you can check more on the GitHub repository, and we are super happy of any contribution by the community. Thank you.